is something wrong with the world of data. You sort of feel it when, there's a frustration when someone asks you for a quick report, and you're like, it's not going to be quick. I know it's not going to be quick. You feel it when there's the dread. Someone asks you to change a dashboard, to change a KPI, to do anything different than you've already set up. There's just dread and frustration. You feel it when someone asks you, oh, hey, we're going to try a new system. We need to migrate to a new visualization tool. Oh, for the love of God, right? Just more pain. You feel it when the costs of your warehouse just spiral out of control, right? You feel it when you just have this exhaustion, when you have to explain again to someone why a simple request isn't actually simple. It's not simple. I felt this. I felt it's like a splinter in your mind, right? Something is wrong. Why is it this hard? It shouldn't be this hard. Why is it so hard? We also start to talk to ourselves and we say, like, surely someone else has figured this out. Surely other people have their data infrastructure and it's perfect and beautiful. And it's not, right? We feel like if we just centralized harder, if we just worked harder, if we had less legacy systems, if we had team members that were more data literate, things would just be easier. We could automate all the things, right? But it's been this way for what, like 20 years, right? The more we invest, the more things stay the same, right? The same pain, right? And in fact, in many ways, we do all this investment and it's not that things get better, it seems like they almost get worse. The complexity grows, the flexibility isn't there. It seems to be the spiraling problem. And it's not just you, right? We tend to think if we're not doing it right? But then you just do a cursory exploration of sort of industry analyses, and there's huge numbers of percentages. You look at Gartner, all these, like 70% of data initiatives fail. The number of companies that are trying to become data driven and they can't, right? There's a whole thing about dark data, right? You've managed to put all of your data into Snowflake and you query 5% of it. What the heck is going on here, right? So I call it a data paradox. We're sort of drowning in data, but we're desperate for any kind of results. We have lots and lots of data, but we can't use it for the things we want to use it for. There's billions spent on this, billions. No, not even an exaggeration. Tons of technology. And then even, we did customer discovery. You think like maybe the big companies have figured this out. We talked to a giant company, an athletic wear company. They have 800 data engineers on staff. 800. And they're supremely unhappy with their data. They can't use it for what they want to do. They can't use it for data initiatives. What is going on, right? It's not just frustrating, too. This is an existential threat, right? Because we want to be able to use this data for new and emerging use cases. AI, you want to be able to try these things, and we just can't. So I think we've accepted a matrix of our own making. I think the heart of the problem is deceptively simple. It's the pipeline. The pipeline is the heart of the problem. It is the foundation of all of our data architectures. You talk to anyone, you talk to any data engineer, and you start to ask them about their system, and they'll start with their pipeline. We have an XYZ pipeline, we run it every hour, blah, 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 blah. And I believe the pipeline is the root of our problems. I think they were designed for a world that doesn't exist anymore. And hopefully I'll convince you of that as I go. So imagine if you had a world, right, where you didn't have to know all of your use cases in advance. Right? When you build a pipeline, you got to know, well, we're going to use it for BI. Imagine a world you didn't have to do that. Imagine you had a world where your engineers were like actually implementing use cases, not fighting pipelines, not dealing with repair, not dealing with maintenance. And imagine if you had a world where your data would adapt to your business, not the other way around. Like I've literally seen this happen where a company was like, well, we can't figure out how to make the KPI work, so we'll use what we have and keep running, and that affects how you actually operate your business. What the heck is going on here? Now, this seems like snake oil. Lots of tools have talked about solving these problems. you probably believe it's impossible, especially given how much we think the problem is complicated. So I'm going to go into a little bit, why is the pipeline the core of our architectures? Okay? Why does it even look like this? It's a series, like when we internalize this, it's a series of steps. You've got your E's, your T's, your L's, you do it as a unit. Maybe you shuffle the pieces around a little bit, but this is sort of the structure. So how do we get here? In the beginning, we had the database. You had the company that ran their database, and they had, they ran their inventory on it, or their ERP system, or whatever it was that their business was based on. And we're talking about, in the beginning, this is like the 70s, right? You had your database, and SQL was new, and so like, oh, I want to ask some questions, ad hoc questions of this database, and they started running these things on the database. And it didn't take very long for people to realize, hey, that's a terrible idea if you're running your business on a database and you're just starting to run some ad hoc queries on it. I'd be curious to see what happened with the first person that ran a cross product on a production database, what happened. So people realized this is a bad idea to run everything. And so what do? They said, and again, in the 70s, we'll have two databases. We'll create a second database to run our ad hoc queries on, and this is the nightly dump. You would take your data when things are quiet, nobody's like accessing your data, and you would do your nightly dump, and you would feed it into another database, and then you would run your ad hoc queries on that one. And things were good for a while. And then in the 1980s, someone had the brilliant idea. They said, hey, if we're using a second database, it doesn't have to look like the first database. We can remodel it. We can shape it in a different way that's actually suited for these ad hoc queries, right? And this is the birth of the data warehouse, right? This is in the 1980s. They first came around in the 1980s. You did your nightly dump. You did some remodeling. You loaded it into your warehouse. Great. If you squint, this is the pipeline. It's the same thing. It's the nightly dump. It's the nightly dump with a remodel. So the basic pattern that we've continued to build all of our data infrastructure on has not changed in 40 years, which is kind of crazy to think about. How much has our use of data changed? How much has our conception of what you can even do with data changed? But this is still the pattern, right? And there's something insidious here, right? Because what happens is the way we build pipelines and the way we structure this actually changes what we can even do with the data. There's all sorts of baked in assumptions, conceptual inertia baked into this that we accept and limit what we can do. So what are some of these assumptions? What are these problems that exist with data, right? One is it has implicit in it an operational and analytic split. So again, this is the warehouse and the operational database from the 1980s. We've ended up building these two universes with the pipeline as the portal between these two universes. And we end up with all sorts of tools in both spaces that frequently are doing the same thing, solving the same problems, but they're just different because they're in different universes. Why? Why do we have this split today? Does this make sense today? Another thing that's encoded in here is the nightly dump. It's the batch. It's the pull. You need to extract data from a source. You need to extract it. They're not an active participant. They're just the operational database that I need to pull data from and extract. And there's an interesting thing that happens here that we've all experienced, at least in industry, where you've decoupled the producers of data from the data infrastructure, right? They're not aware. They're just like the bone to suck the marrow out of. They're not really involved in the system. And this is, again, encoded in the idea of pipelines. Now, recently there's been people trying to rectify this a little bit. You hear about data contracts and things like that. I think that's a little bit of a band-aid of trying to apply strong constraints to a system that wasn't designed to actually involve the producers in the data. No, you can't change your scheme anymore because you have a contract. I don't think that's how people actually want to operate. So another thing that's encoded is that pipelines are point-to-point, right? You go from A to B, source to destination, operational system to analytic system. Why? Why is this the case? This is just encoded. We accept it. This is how we've built all of our infrastructure. The other insidious thing about this is that the pipeline encodes the use case. How many times have you been talking about your pipelines and someone says, "Oh, that's the analytic pipeline, that's the ML pipeline, it's encoded inside of the pipeline"? Why? Why is that the case? There's also, it's one way. All data flows one way, upstream to downstream, right? It's funny, I have this, like, again, splinter in my mind. You see this whole industry segment, reverse ETL. What the hell does that mean? Reverse ETL. That means there's one right way for ETL to go and everything else is reverse. Why? Because we've just encoded, we've accepted all of these assumptions about how data moves. Another thing is we have this impulse to put all of our data into one place, right? Again, this is the data warehouse sort of rearing its head again. We want to put everything into Snowflake, or we want to put everything into Databricks, right? One place, one system for all of our data. And again, this one system frequently encodes a use case as well, right? What is a warehouse for? It's for running analytic queries. Now we're putting all of our data in it. Does that make sense? So I hope I've convinced you a little bit that this isn't how our world looks anymore, right? We're using a tool that was based on one operational system, one warehouse. But this isn't how we want to use data. This isn't how our companies operate. This isn't how data flows today, right? What does it look like today? Kind of looks like this, right? You've got an explosion of sources. You've got an explosion of destinations and use cases coming all the time, right? And we're trying to apply this tool that was intended for a single source and a single destination and applying it to this. And I firmly believe this is a huge source of the friction that we've experienced as an industry for decades, right? Whenever someone had a new use case, what happens? Oh, we can't do that use case. You can't use that data for ML because it wasn't designed for that, right? It's causing a lot of this friction. And it also creates this thing where we start to make all of these decisions in our data infrastructure around an idea that getting the data is the hard part, right? You want to move all your compute to the data. Why? Because getting the data is the hard part, right? Data gravity, if anyone's heard those terms, right? It's because moving or getting the data is the hard part. What if it wasn't? What if that wasn't the hard part? How would your data infrastructure change? How would your conception of what you could do, how would that change? So if the pipeline is the root of our problems, or at least one of the roots of our problems, what do we do? What do we do? So I contend that what we need to do is deconstruct the pipeline. We need to deconstruct this idea of all data flows as a unit, as ETL, right? You break it up into its constituent parts. So this is what we're doing at Matterbeam. We deconstruct the pipeline. And so the first part of how we deconstruct it is we say, imagine the E of an ETL, but instead we call it collect, because we don't have a use case baked into it. We can collect data from sources and store it in an immutable log. So you don't need to know where it's going. You don't need to coordinate a sink or a destination, and you can store data immutably. Then you can stream that data at any point. So now you have the separate piece, which is we call emit. So it doesn't have to happen synchronously. You can take that data and emit it to a target. You can pause the target. You can recreate the target. By using this immutable log, you can now have control over where that data goes when you're ready to use it in the shape that you want to use it. So if you're doing both at the same time and you squint, this is kind of a pipeline, right? You're collecting data, you're emitting data. We're fundamentally a streaming platform, but you're moving data. But the flows, the sides become independent and scalable, and you can control them in different ways. Now the real payoff is that now you can take that same data and you have infinite possibilities on it. You don't have the one use case end to end that's blocking everything that you want to do. Now you can take that same data, that data that you had for BI, you had for analytics, you had for some other purpose, and you can feed it into another use case, something that you hadn't even thought about before, a tool that doesn't even exist yet. It's this idea of multiple sources, multiple destinations. So one of the key insights is this power of immutability, right? We create these logs of immutable data that don't have the use case baked into it. Frequently when we do pipelines today, they're destructive. You know what, this BI job doesn't need North America. We filter out North America, we don't care, and that's gone. Here we immutably store the entire source data set and then create derived views, right? It gives you this power of mechanical repeatability, of time travel, to rewind and replay and do different things with it. It gives you this power of fearless exploration. So here's some terms that we talk about in rethinking data. Like, instead of a pipeline, not everyone knows what a manifold is, but it's like a dynamic data manifold, right? One input, lots of outputs. You can take it to go anywhere. You can time travel. You can move data whenever you want to. Like 6 months from now, you can still materialize that Postgres database if you want to in a different system. And another key idea is this idea of late transformation. With a late transformation, there's all this hubbub about data products, but data products are still an encoding of a use case, right? With a data product, if you could do a late transformation on that data, you could make a data product that suits your use case right at the moment when you need it, which is kind of a superpower. So a shift from pipelines to more immutable streams enables a completely different data architecture. Instead of a nest of point-to-point connections, everything flowing into a data lake, maybe some of it going into a warehouse, who knows, you can build a hub and spoke model where things can become peers on this, where there's no directionality, there's no use case baked into it. The use cases can emerge dynamically from what you're doing. So I think this transformation is becoming even more important right now, because we have some customers now that want to explore AI use cases, right? And you can imagine taking their data sets, their Postgres database, running it into a Pinecone, into a vector database. It's easy. It's not a 6-month effort. It's a 10-minute effort. I can connect this to a new database, and I can materialize it when I need it. So how do we break free of this? Where do we start? Most tools don't work this way. Most of the industry doesn't think this way. A lot of things don't map to how we do data. But some core ideas, these are things that we built into, this is why we built Matterbeam, but some of the core ideas is fundamentally streaming. Streaming is actually a more fundamental way to engage with data than batch processing. You can make batches out of streams, not the other way around. Immutable, this idea of immutability is super powerful. Most people don't quite get why it's important until they experience it, and then they're like, holy crap, I can actually get that data that I didn't record early on. You want to have some way to easily interchange that data. We have our own proprietary format, but you can imagine Arrow taking the place of this, or a Parquet or something. I still think these are more use case dependent, like Parquet is really designed for analytic workloads as a columnar store, right? But you want some kind of common interface. And of course, piecing all this together is hard. Again, why we built Matterbeam. So real results, right? We've had customers take development efforts to go from 90% savings from months to days. Migration plans cut radically. 60% reduction in infrastructure costs. 10x time, faster time to use. But I can sit here and spin this vision. I can talk about it. Everyone will always have the oh, I've heard this before. This is BS. I don't believe you. So I've actually invited Josh, who is one of our customers, to talk a little bit about how he's used Matterbeam and how he's engaged with these ideas. Josh is the VP of Engineering at Broadlume. Broadlume is a technology company that's providing digital solutions for flooring vendors. So you can think marketing solutions, website solutions, ERP solutions, things like that. And I'll hand it off to Josh. Thank you so much.
Thanks, Mike. So yes, I'm the VP of Engineering for Broadlume, and was introduced to Matterbeam. They said, give me your most difficult use case. So I threw a Cobalt application at them that was not even a database, really, technically. And I said, we've got this thing where we move this to a real database for reporting, and we don't know how it works. Somebody wrote it that's been gone for 20 years, and so I'll let you guys tackle that. So we put that into the system and got that thing going, and that looked like a normal pipeline. But then I had one of my engineering managers say, hey, there was a ticket on the backlog to kind of pull this information and find out how many users we have across all of our, because this is not a modern application, so it was not multi-tenant. And so he said, I think it was like 3 weeks worth of work, and I figured out that we already had the data in Matterbeam, and so I did it yesterday. It took me like an hour. And so we started to look at that, and we started to change the way we looked at things because we had all this data in there. And then, I had our products managers came to me and said, hey, we've got all this data in here. We need to push it to another system via an API. Can we do that with Matterbeam? We've already got it. And of course we could because it was there already. So for us, it's really changed the way that we look at how we do data. Our product managers get really excited when it's a data project and we can use Matterbeam to make it go a lot faster. But this immutable log, I think, was missed on me at first when Mike was talking about that and why that's important. I didn't really grasp it until I realized, with something like a 5-tran or something like that where you're moving stuff back and forth, it's for that point in time, right? But with Matterbeam, we've discovered we could go back to 6 months ago how the database looked and emit it that way and actually get it out just that way. We can make changes downstream so we can add a field, and because Matterbeam captured the way it was, it can then just add that field to the data set. It also changes the way we look at analytics, right? So in the classic model, we were doing the same thing. We were dumping everything to a data warehouse. We started to think about it. We said, we have all this data in Matterbeam. Why don't we just emit the report that we want, like we want it? We can save the compute and the storage and all that in our data warehouse. And so now we completely changed the way that we do that. So for us, it's definitely revolutionized the way we do things. We just think about everything very differently, and it's much easier. So now we throw all of our data into Matterbeam, and whether or not we need it later on, we'll find out. But we have it there. We can emit reports. We use it for production items as well, not just reporting. When we need to connect two systems, we do it through Matterbeam if we can. So yeah, I think.
All right. I don't know what. We're close to time. We could probably take a couple of questions if people have. I don't know, maybe I'll leave it to the MC. Do we have time for questions?
Yeah, we definitely have some time for questions. Anyone? Can you explain a little more in depth the immutable log? What does that look like? How do you interact with that?
Yeah, so the immutable log is not actually intended for the end users to interact with, right? The way, one of the inspirations for Matterbeam is this idea of if you think of a relational database, you've got a commit log or a write-ahead log. And internally, the database uses that to create different read representations of that same data, right? What we're trying to do is take that commit log idea and blow it up to your entire company scale. So now you have a commit log of all of this data that you can then emit and transform into your read views, the way you want to query it. Use Databricks for what Databricks is good for. Use Snowflake for what Snowflake is good for. Use a graph database, use whatever. Now you have that flexibility to replay that log and materialize it however you want. Internally it's a proprietary format, but it's basically a log structure with metadata to allow what we call a common record format. So internally we can take those records, do transformations on them, so you can do composable transformations, and then replay that data. You can replay after a transform, before a transform, the source, all of those become possible. Right now it's a GUI. We have a thing where you can create collectors, you connect it to transformations, you build all that in the GUI. On the roadmap is to have more API-driven controls. We have some, but not enough to truly drive the whole system. And we're building MCP on top of the whole stack, which is really where you start to go crazy, where you say, hey, agent, tell me about my data. How can I do? And it's kind of spooky, actually. But